Hi, this is Jason Radford, and welcome to our workshop on cognitive tasks with jsPsych. This is part of our summer workshop series. We have two left this summer. The next one is going to be on creating multi-person studies. The focus will be on different kinds of multi-person studies and designing multi-person studies and thinking about how you would actually engineer it with a little bit of code work at the end. So if you're interested in just thinking through how to build a multi-person study and want a little intro into the coding part of it, feel free to sign up. Our last workshop is going to be building your own study pool or subject pool. In this case, we'll be talking about how you recruit subjects, panel them, and then engage them over the long term as you conduct a longitudinal study or as you use them or recruit from them for future studies. If you're interested in either of these, please register at volunteerscience.com/events. On to the show. Today, I'm going to start with first an introduction to jsPsych. What is it? When do you use it? And how does it work? And then we'll end off with a coding example. Now, the coding example is going to be in a separate video, which should be linked in the description. So just for this part, we'll talk about the conceptual introduction to jsPsych. So, what is jsPsych? It's an open source JavaScript library for behavioral experiments built by a faculty member at Vassar named Josh DeLu and with 60 plus contributors to the GitHub page. So if you go to jspsych.org, you can find the core website, and then there's a JSPsych library on GitHub. The focus of JSPsych, as said in the name, is psychology experiments, mostly cognitive tasks, and subjects like perception, language, reasoning, and so on. Now, JSPsych's specialty is timed tasks. So showing some stimulus for a certain period of time or for an indefinite period of time and having a measurement of how quickly somebody responds to that stimulus. So tasks in language processing can involve showing somebody a word and asking them to classify whether it's an English word or Spanish word or French word, or showing them a string of letters and having them classify whether it's a word or not. A memory or recall task can involve showing somebody a sequence of numbers and then having them remember the third number in the list. Or having, showing somebody a picture and having them recall what's in the picture. Lastly, an identification or labeling task can involve showing somebody an image or a word and having them classify that word as a part of one group or another, as we'll see with the implicit association task. So this is what JavaScript or JSPsych is really built for, is these kinds of show somebody a stimulus and time their reaction to that stimulus online using JavaScript. But there's a couple of other add-ons to it which make it even more powerful. So they implement eye tracking using WebGazer, the WebGazer.js library. That would be a very advanced tutorial if we were to go through the eye tracking features. So we're not going to do that today. If you're interested in that, certainly vote on it in all our ideas poll for the workshops that we'll do this fall, and I'm sure we'll do some in the spring as well. They also have support for item sorting tasks. So if you wanted to give people a set of 4 scenarios and have them rank those scenarios, slide them into a sorted list if you want, that's something that you can do. And they also have some support for creating your own surveys. It's a couple of basic question types that you can add into JSPsych. So just as a couple of examples, on the left-hand side we have this implicit association task that I mentioned earlier. In this particular version, this is using images to classify something as old or young. The screen grab here is a picture of a young person. So the idea is you would see this image, or you would show the image to a subject, and their job would be to press the E for old or I for young as quickly as possible. And the study is how quickly do they classify old and young faces, and you're measuring how quickly they press E or I and whether they press the right button. On the right-hand side, we have lexical decision task. The entry here is classifying whether it's a word or not. So this is meant to be the word grabbing, but a good way of creating non-words is by taking an existing word and switching around a couple of letters inside it. So this would not be a word. And the entry here is yes or no, is it a word or not? Y or N. So how does jsPsych work? So this is just getting into the guts of when you want to create an experiment, how do you go about doing that? And this is going to be sort of a high-level overview of how it works. And then in the code example after this video, we'll go into the nuts and bolts of it. So I like to liken jsPsych to the Legos. So jsPsych has a set of sort of core tools that make up its library. And these are like your standard Legos. So these tools can be rendering images, loading images, sequencing, uh, different kinds of tools. These are all sort of the basic elements of the library. So the first thing you do is you bring in the specific kinds of tools that you need. The second thing that you then do is add specific assets for your study. So in the IAT example earlier, the images right here, the image of the young face or old faces would be considered assets. So you add the specific things that you need for your study. Another example may be lists of words that you want people to classify. So these assets can include these images and words, but they can also include specific functions like randomization functions or functions to create specific sets of instructions or strings based on um, the particular kind of experiment that you are trying to do. What you then do is you use the tools and the assets to create an instrument. So this is sort of the Ferris wheel, the standalone thing that somebody is going to be engaging in. So this can be a survey, it can be the instructions, or it can be a trial where you're showing somebody the sequence of images and they're having to classify each one. Lastly, you arrange the instruments into what's called a timeline. And the timeline is an essential part of how jsPsych works. The timeline basically takes these built instruments, these standalone pieces, and sets them up in an array. So they go from the Ferris wheel to a house to the beach to the fire station, or in this case, from the welcome page to the instructions to the first trial to the second trial to the third trial, and then to the debrief page, the end of the study. And that's how jsPsych works. Tools and assets are used to build instruments, and these instruments are arranged in a timeline. So, what is the timeline? I want to keep hinging on this because this is the ultimate end for any kind of building that you're doing within jsPsych. You are creating the welcome, you're creating an instrument, creating instrument B, creating the debrief, and the timeline just says, I want the welcome first, I want the instrument A next, instrument B after that, and then the debrief. How does this work within volunteer science? Volunteer science has a couple of different operating assumptions from jsPsych. jsPsych doesn't assume that you have a place to save data, for example, and so you have to figure out how data should be saved no matter where you are, no matter where you're using it. So with volunteer science, the first thing that you want to do is upload the jsPsych library to volunteer science. You theoretically can upload the entire thing. Very frequently, you do not have to upload the entire jsPsych library, but only certain files that you would need. At the very end, you also want to save the data to volunteer science. So there's a submit function that when you call the submit function, you pass some data to it, it just saves that data no matter what it is. So that's the integration at a very high scale or high level. So let's go through this step by step. How does this work? So step one, you're importing your tools. As I mentioned, JavaScript or jsPsych is like Legos. These are the core Lego pieces. So the core library, which is called jspsych.js, it's a single file. It's something like 3,000 lines of code. That's where you create the basic timeline, or that's where the variables and functions and class timeline are handled. The data handling functions are all there. The core functions for the jsPsych library are there. The second tool, or really a set of tools, are all the plugins. And these are the individual pieces that make individual things work. So keyboard response as a plugin. So if you want to have people put in answers from the keyboard, there's a little plugin for that. If you want them to click a button, there's a plugin for that. There's a plugin for handling audio stimuli. So if you want to play a sound and have people classify it, you can use that plugin. Same thing for images and animations. And then WebGazer is its own plugin. You could find the list of plugins at jspsych.org/plugins/list of plugins. um, it's a very convenient list of the Legos basically that you have to play with in your JSPsych. So how do you actually do this in a study? Normally, if you're using just a JSPsych for your own on your own website, you set up the head. There we go. And now I have my mouse. You set up the head tag, and in the head tag you say script src, which stands for source, and you set it JSPsych 6.3.0, which is the version number. That number will change. Certainly in the future, it's going to get larger and larger. So just pay attention to which version of JSPsych you're using. It'll say in the file in the folder. JSPsych 630/jspsych.js. And what that's doing is it's pulling in this jspsych.js, the core file, into this person's browser. So basically, it's telling the browser to download this JSPsych file. Second thing, you import all of the plugins. In this case, I'm just using one plugin, the JSPsych HTML keyboard response. This particular plugin is for showing somebody an HTML stimulus, which can be just a list of numbers, or it can be a string, or it can be an entire vignette. And then taking as a response some input from the keyboard. That's basically all this plugin does. And lastly, there's a CSS file which formats the JSPsych interface into a way that JSPsych is sort of expecting. We almost always use the jspsych.css because we don't want to make different assumptions about what things are called or what objects exist in the window or in the page. But normally you put all of the stuff in the head. Step one, you create the head and you import all of the Legos that you want. And then when you want to actually do something with them, you put them at the end of the body and the script at the bottom. Oops. Now with Volunteer Science, you don't do any of that. All you do is upload your files to your experiment in Volunteer Science, and I'll show you how to do that in the tutorial next. But basically, you just take those same files, jspsych.js, JSPsych HTML keyboard response, and JSPsych CSS, and you upload them to your study, and they will be available. Step 2, adding in assets. So adding the images, the list of words, any kind of utility functions. Again, the idea here is that you're putting in content that you need, specific functions for your study that aren't available in JavaScript or JSPsych, and then some special variables. And typically, the variables can be the number of trials that you want people to run through, the number of iterations per trial. Their key response options. So should people be pressing, E and I, or W and O, or A and L? What are the specific entry keyboard entries? And what is correct, right? So if all of the if the orange circle, as we'll show in this example, is the correct one, then people want to be pressing A, and so A is correct for the orange PNG file. You'll see what I mean by that in a second. So here's an assets example when you're bringing them into your JSPsych study. Remember, here we had the head where we're pulling in the core files, the basic files. Down here in the bottom is where we're going to be adding in these assets. So down at the bottom is script tags. You say, for example, you load in your images. You say images equal img/blue.png, img/red.png. And basically what this is just creating a list of the images that are that you'll be using in your study. Now this is not by any means a complete study. This is just an example. We'll do a complete study in the demonstration. Another example of an asset that you can use is a randomization function. So I've created a function that says pick one, and what this function is doing is it's taking these images, this list of 2 images, and it's picking one at random. So it's using a common randomization algorithm in JavaScript. We say math.random times the length of the image, so it'll pull out 0 or 1, and then it returns one of these images. In Volunteer Science, the only thing that you change in these assets, the only thing that's different, is how these assets are stored. So you upload this blue PNG to volunteer science, you upload the red.png to volunteer science. These are images of red and blue circles, just to give you a specific idea in mind. These are meant to be images of circles. So instead of saying image slash blue.png, volunteer science uses slash attachment. That's where everything is stored. So when you upload a document to volunteer science, to one of your experiments, you can access it using slash attachment, slash the name of the document. Now remember to always put the slash before attachment. Don't forget that slash, it won't work without it. All right, step 3. So we're actually going to create a trial. We're going to take these assets and these the core tools and create a specific trial. So the essential elements for a trial are picking the type of Lego that we're using here. So the particular plugin usually. So instructions, survey, IAT, keyboard response, or audio keyboard response, etc. Each one of these elements, whether instructions or IAT, have their own unique arguments or essential components. So the first thing you do is you set the type. So this is a good example here on the right-hand side. These trials are stored as objects in JavaScript, so you create a variable. So you create a variable, I'm going to call it image response task. The first thing I'm going to do is I'm going to set its type. And that type is just telling jsPsych which element we're using. So image keyboard response is the element that we're using. Check the jsPsych documentation for exactly how to express the component name. So it's usually the same as the plugin, but not always. So the image dash keyboard dash response is the way to denote showing an image and pressing the keyboard to input the answer. The next thing you put into these components are the stimulus. You got to tell us what you're going to show. In this particular case, there's a function that's being created elsewhere that is defining that stimulus. Generally, if you're doing an HTML stimulus, you could also just put the HTML text right in here. And that'll also be another part of the example code in the second half of this workshop. You then give the choices. So what can people press, or what do people select to register a response? So we know this is going to be an image keyboard task. The stimuli are the images. Again, you can't see that, but that's just what's happening here. And the choices here are F and J. So somebody can press F or they can press J, and anything else is not going to be registered. Another component typical of most everything is data. So you can add pieces of data for each time they respond. So we want to be able to note that this is a task where the value is response. And this will come out as a column in your spreadsheet. So it'll say task and the value for this particular row is response. Same thing here, the correct response will say, okay, which was the correct response for this particular image. And again, this is something that's happening in a separate function, so which we'll show in the second half of the tutorial. And lastly, another essential component. Now there are more components than these. For each particular kind of element that you want to be using, make sure you check the jsPsych documentation for what components you have to put in here and what you have control over. These are generally pretty useful, commonly used for all of the elements. So on finish, so what happens when somebody finishes the task? We want to log whether they were correct. So this is what's happening here. So on finish, we create a new function where we're adding to the data whether they were correct. So it's pulling in, let's see, another plugin API. So using a plugin to compare whether the person's response, data.response, was the same as the correct response, what we're expecting. So all of this stuff works the same in volunteer science. You don't have to do anything different when creating trials with volunteer science that you're not already doing here. So if for whatever reason you're pulling the image in here, make sure you're using attachment instead of IMG. But generally everything else is the same. Okay, so you've created a task. This is the task. We're showing in the images and pressing a button. We're not going to talk about all of the other tasks. We'll do that in the example. But that's an example of creating a specific task. Next, we want to arrange all of the tasks that we create into a timeline. This is very easy. There's very little complexity to this. So remember, timeline is this core sequencer that's saying, I'm going to create this task called welcome. I'm going to create a task called instrument A, a task called instrument B, and a task called debrief. And the only thing I need to do in my study is at some point define it as a timeline with a list. So the example on the right-hand side is timeline equals, use these square brackets, because it's JavaScript, that's how you create a list. Square brackets, instructions, image response task, and survey, as this example. Remember, I called this image response task. Oops. Yeah. So you want to reuse those same variable names. So somewhere else I've created a variable called instructions, which is this HTML thing, and a survey as well. And now I'm just putting them in the timeline. This also works the same on volunteer science. You don't have to do anything different for volunteer science. Create the timeline as normal. The last thing you'll need to do is figure out how to save the data. JSPsych doesn't have an assumption about how you're saving data. It's running in a person's browser, so it doesn't have a place to save it natively. So usually you're running this on a server somewhere, or distributing it from a server, and you need to save it back to that server. And there's a way to do that. I'll show you how to do it with volunteer science because I don't know what server you have and how it's configured. But generally, the way that you do saving the data is through this jspsych.init argument. So the way that JSPsych init works, the reason that it works, is remember we have this timeline, which is sort of like a tour of the city here, the city of experiments that we built. What you need to do is you need to tell JSPsych and the person the conditions in which they start. So JSPsych init will tell us where you can set whether it's a full screen experiment or not. Display element tells us where on the page to display the JSPsych experiment. So if you don't want to do full screen, you want to do it on a particular place in the page. Display element is where you set the particular place. On finish and on trial finish are also arguments that you can put into this JSPsych init, and I'll show you what that looks like in a second, to control what happens when the study is over and when each trial is over. So here's an example. The left-hand side, again, JSPsych does not know where you're saving it. So, and this is what's the example given on the JSPsych library website. The way that this works here is, JSPsych init timeline. You set the timeline variable. So if you call your timeline, you make it timeline here. If you want to call it, tour of the city, you have to name that variable tour of the city to say timeline, semicolon, tour of the city. Next thing, full screen, true, false. False if you don't want it to be full screen. Oh, I forgot a comma there. And then on finish, so when the study finishes, what you want to do is you want to run a function where you say jspsych.data.display data. So on finish requires a function, I believe, to run. For volunteer science, there's a couple of things that you're going to do differently. First, you're going to change the display element to main-test. And main test is just the basic window within volunteer science where you're running your experiment. You can run it full screen if you want to, but then people really lose their orientation and have a hard time figuring out how to escape an experiment. So if somebody wants to stop, what they need to do is press the quit button so that they formally close the experiment and then go on to do other things. So it's better to keep it either as in the main test or with the full screen true with an ability to press the escape button to clear out. The other thing that you want to change for volunteer science is how the data is saved. So, there's three things. The on finish is also something. So with volunteer science, we recommend using on trial finish to save data. And the reason for that is we want to be saving data as it's being created during the study as opposed to when the study is over. And a part of that reason is if people are only partially getting through, we want to save the data, even though somebody doesn't finish the study. That way we can get some semblance of traction on who's not finishing the study. And it may be that partial data is still useful to the researcher. The other thing is we don't want somebody to finish the study and then have to wait for the data to get saved to our server for them to move on. So if somebody, say we're working with with like lots of data or images or something that is um, takes a while to save in JSPsych, or from getting from a person's computer to our server. We don't want somebody to finish the study and have the data start to upload to our server, and then they close the web page and lose the connection, because then you won't get all the data. So we use on trial finish, the on trial finish argument, to save data. So every time they finish a trial, the data gets saved to volunteer science. The way you do that is you say on trial finish function data, and then d equals jspsych.data.get last trial data, which just pulls in the data from the trial that they just finished. And then submit.d.csv saves the data from that trial in the CSV ready format. The d.csv is something that JSPsych has natively. So we're using the JSPsych library for the .csv argument. So every time the trial finishes, we get the data from that trial and save it in the CSV format, CSV ready format. The last thing, which should be bolded but it's not, is this on finish argument. So when the study is actually over, volunteer science has a specific function that we call so that our system knows that the study is over. And so you want to use that. It's experiment complete. So on finish, we call experiment complete. Okay, so this is the end of the conceptual overview. We're going to do a coding example in a separate video. And the way that the coding example is going to work is we're going to create a welcome page. When somebody lands, it says, hey, welcome to our study. Instructions page telling people what to do, and then we'll do one trial of picking blue or green circles 5 times, and then a debrief. So this is actually going to be the core reaction time task that JSPsych uses in its tutorials. So we're going to walk through how to take the tutorial that exists on JSPsych and put it up on Volunteer Science. So thank you for coming to the conceptual part of our workshop. Just remember, we have 2 more workshops, one on creating multi-person studies and the other on building your own subject pool. If you need help or have any questions, please feel free to contact me at jason_radford@volunteerscience.com. And if there's something that you'd like to see, a tutorial or a workshop that you'd like to see us do this fall, please go to our allideas.org/vs-trainings page and vote for some of the ideas that are already up there, and add your own ideas if you don't see them amongst the voting options. All right, thank you so much, and I will see you on the coding example.